Good morning, good afternoon, good evening, everyone. Welcome to the Tech Talk today. Today's webinar is part of Tech Talk X series by Digital at INSEAD. It is dedicated to exploring new digital technologies, their applications, as well as their impact on management, business, and society. For more information, please visit Digital at INSEAD website. And of course, thanks to our sponsor, Accenture. So for today's webinar etiquette, the audience will be muted. The video and chat functionalities will be disabled. Should you have any questions, please use the Q&A tab. Please keep your questions short and to the point. And to help identify the most relevant questions, please also vote on the existing questions. This webinar is recorded, and should you encounter any technical issues, email digital@insead.edu. So, welcome again. My name is Anton Ovchinnikov. I am a visiting professor of decision sciences, and today we are myself and Virginie Simon, a 24J MBA student and a founding member of INSEAD AGI Club. So we will be working together today on a recent research paper of mine titled "A Manager and AI Walk into a Bar. Does ChatGPT make biased decisions like we do?" Right, so I will now start sharing my slides, and we will go from there. All right, so for start, what did I do? I went to ChatGPT and I said, generate me an image for a webinar manager and AI walk into a bar. And so this is an image that I got. Now, is it a super creative and good image? Well, that's up to the beholder, but it's certainly much better than what I would have been able to draw myself in a couple of minutes. Now, then I said, okay, regenerate me another one, and here's what I got on the second shot. Here, realize what we see is a well-known thing called hallucinations, right? So you see up on the top, a manager and AI walk into a bar, right? That's more or less normal, right? Except that there are two A's, but at the bottom, right, does it make biased decisions like we do, right? So here you see there's quite a lot of like non-legit words. Well, in any way, so a brief history of how we got here. The AI going back to 50s, right, where and in the first 50 years, from 50s to 2000s, there was a triangulation of algorithms, compute power, and storage, and data, and there were many different approaches to learning, many different approaches to what intelligence is. In 2014, one of those approaches, based on neural networks, kind of proved that it is a way to go, right? So what happens in 2014, a research paper by this team of Krzyzewski, Sutskever, and Hinton, they showed that this artificial neural network-based model outperforms significantly in image recognition. Then in 2017, another research paper by Google Brain called "Attention is All You Need" introduced the transformer neural network architecture for machine translation. 18 to 22, growth of various large language models. OpenAI released, its first GPT in 2018, and then it's kind of GPT 3.5 called Instruct GPT in early 22. Right. So here, what I'm pointing out with colors here is that I'm making OpenAI in green, and you also see the Sutskever on the 2014 paper. So I think all of you have heard recently this name, right, in regards to the kind of Sam Altman ousting and then coming back, right? But realize that that's the same person who was on the paper in 2014 with Hinton and the likes. So then in November 22, OpenAI built an app on top of Instruct GPT, and that's what we know today as ChatGPT. Again, I think everybody here knows what it is. And so today we are in this kind of arms race for bigger and better large language models. There's enormous hype across all domains of the society around this. Right? Okay, so Now, what do we need to understand to move forward? We need to understand that the key breakthrough in the recent years is in rethinking of meaning of language and rethinking of meaning of translation. So before 2017-ish, AI used to have separate fields, like image recognition was one thing, voice to text was another, speech generation was a third. But this transformer architecture, so again, let's go back here, this 2017 transformer architecture allowed to unify all these fields into language. And this has two main implications. One is there's a major speed up in progress. And two, that we need to start thinking about many tasks as translation. Right? So in terms of implication number one, right? So over here, look at this horizontal line at 0, which is a human performance. And here we can see how long it took for machines to reach or exceed human performance, right? And we see that, for example, in speech recognition, right, from kind of before 2000s and up until about 2017, that's when machine became more accurate than humans. And you see that this is kind of relatively slow progress. But recently, these lines are almost straight up, right? This progress is essentially, right, very, very quick, right? Because all of these fields are now contributing to one another. And implication number two is that we really need to kind of expand our world in terms of what translations are. Right, so here is translation between one spoken language and another spoken language. Right, up on the top is between English and French. So the phrase in English, "I'd like to try on a suit I've seen in a shop across the street from our hotel," right? And you see that in French, well, "je voudrais essayer," etc. Right, so the phrase is almost identical to English. Right, you can argue it's an easy to translate a pair of languages. In the middle is English and German. And again, you see that it's more or less the same with kind of one difference of a certain thing moved to the back. At the bottom is English and Turkish, right? And you see that these languages are in many ways completely different, right? So in fact, this sentence is exactly flipped, right? But nevertheless, machine translation today is kind of comparable to professional translator in many, many languages. But of course, that's only one way of thinking about translations. You can think of translations between a spoken language and a programming language. Right, so here is a query in English and an SQL code at the back. You can also think about translation between spoken languages and image, right? So here is a spoken language phrase, right? Catholic Pope Francis wearing a Balenciaga puffy jacket in drill wrap. And this is an image that is generated by, this is by by a model called Mid-Journey, right? But this is an image that is generated, right, in response to that prompt, right? So think about it. This is a translation of that spoken language phrase into a graphical representation. Now, of course, that's not a real image of Pope Francis, right? This is an AI-generated image of Pope Francis. And we can continue on and on and on. The last example I will show to you is that here's a translation between the echo of a Wi-Fi signal and seeing remotely at any distance and through the walls. Right. So when the Wi-Fi router emits the signals, right, and the signals hit objects, right, they kind of bend slightly, right, or there's a bit of an echo, right, and we can now use this echo to reconstruct the objects that are in the room. Right. Think about it. We can see through the walls at any distance, right? Not in a very great quality, but at least we can see, for example, the shapes of the objects, right? So here you see the shapes of people that are reconstructed from these Wi-Fi echo signals. All right, so, and this is just the beginning. The key point is that many problems could be thought of language and translation, and that is why we're talking about large language models. Like GPT, like ChatGPT is an app built on them. Okay, so on what data are these large language models trained, right? So here is the ChatGPT 3.5, right, which is before fall of 2021. And you see here that kind of all of Wikipedia, right, around 3 billion words, right? All the books that are on the internet are about, let's say 70 in total. And the majority of the data, right, is what's called common crawl, right? Common crawl is essentially all the text that is on the internet, comments, questions, and so on. Right? Again, this is what on what the original ChatGPT was trained for, but the newer models are almost always multimodal, meaning that they're not trained on just text, but also on images, sound, etc. Right. So here it's a little bit of a busy graphic, but in terms of color, look, I highlighted in pink, right, these multimodal models, and you see that almost all of the newer ones are in fact like that. Right. And again, the reason this happens is because we're now thinking very differently about translations, and we realize that this language, that the image and sound and text can all be viewed as language. All right, so this is on what kind of data they are trained. Now, how are they trained? And here are the here is a key breakthrough in GPT performance. It comes from the following. So at the beginning, in step one, right, these models are trained through a supervised learning policy that predicts next word. Now think about it. We all live in a yellow. What's the next word? Submarine, right? We all live. There are many possibilities: in, during, on, and so on, right? So now these models being large means that they can predict not just the next word, they can also predict the next sentence, the next paragraph, right? That's kind of the benefit of being large. But anyway, that's just step one. In fact, this is not particularly new. This has been done for a while. The new part is this step two, which is what's called reinforcement learning from human feedback. So how does it work? So this model that is trained to predict the next word, next sentence, next paragraph, right, generated 4 predictions, and these predictions were given to humans, to actual people, to real people, right, who ranked them. And for example, here, right, explain the moon landing to a 6-year-old, right, it generated A, B, C, D, right. These are four responses, right? And then this person labeler said that, well, D is better than C, which is better than A, which is about the same as B, right? And now this data was then used to retrain the model so that the responses it produces are kind of mostly Ds, right? So that they are as best aligned as possible with what people thought to be most helpful, right? So this part in the middle. Okay, so with this, we're sort of, let's just wrap up the technical part in terms of what these models are and how they train, and let's talk about how they're used. And in that, what I want you to think about is that they are, think about the value chain of organization, right? And that these models are used within the organizations. So for example, Gartner predicts that by 2026, 100 million people will engage with robo-colleagues, synthetic virtual colleagues, to contribute to enterprise work, right? That is, these models will be used by the people within the organization. Next, these models will be used by your value chain partners. So for example, Walmart is using AI to negotiate best price with some of its vendors, right? And so here are some quotes from this article. The system asks Walmart to set budget requirements, and then it compares the supplier demand with trends and then and after that, AI can strike a deal within a matter of days rather than weeks or months, right? So again, your value chain partner could be using generative AI, large language models, right? It is mainly used for savings on small contracts, right, that aren't necessarily worth kind of human intelligence. But the most interesting part is that it turns out that the vendors prefer negotiating with AI rather than with Walmart employees. So 3 out of 4 suppliers prefer handling with AI over a human. Now, my understanding for why this happens is that because of the speed at which decisions are made, right? So a human may, not respond for a few days or so on. AI is much faster. That's my intuition. So anyway, your own people can be using it, your value chain partners can be using it, and then of course your customers can be using it, right? So here is from a financial services setting, right? A whooping 54% of Americans use ChatGPT for personal financial recommendations, right? So in other words, there's a lot of use of these tools, but both within the company, between the value chain partners, and between your customers, right? And so as these LLMs continue to demonstrate human-like abilities, people will use them as advisors and or delegates, right, in these decision situations. And since behavioral science examines the decision biases of people in all these situations, that is, people inside your company, people at your value chain partners, or people of your customers, should we do the same for LLMs? And here, the arguments kind of pro biases is that these models are trained on human data, And of course, this reinforcement learning with human feedback also put human kind of at the very center of training a model. Now, of course, the arguments against biases is that this is a computer model. It can be fully rational. Right? At the end of the day, it's just pure calculations. Right? So therefore, what do? Right? We take decision biases, behavioral biases, kind of in a sense of thinking fast and slow book, right? And then we explore to what extent these biases are present in large language models. Right? Specifically, what we did is we took a research handbook called the Handbook of Behavioral Operations. And from that book, we took a specific chapter called Biases in Individual Decision Making. Right? So we sourced this list of biases that are most relevant for operational decision making. Right? And that chapter presents these 18 biases that are split into 3 groups. Right? Biases in judgment regarding risks, right? Such as, for example, the conjunction fallacy, overconfidence, and so on. Then biases in evaluation of outcomes, such as risk aversion, frame and endowment effect, sunk cost fallacy, and so on. And heuristics in decision making, right? Something on the system 1 and system 2 decisions called cognitive reflection test, CRT. And so what did we do? So there are 18 biases here in total. So what did we do in this research study, right? All of them are one-shot individual decision tests, and all of them have large kind of body of scientific literature or behavioral science literature, which identify these biases. So what did we do? We went to the original research studies, and we took the experimental instructions that were done with people, and we then replicated them with ChatGPT, right? We, depending on the bias, we had between 10 and 100 repetitions of the original experimental instructions plus 2 reformulations. And I'll talk about what they are in a minute, right? When we use both GPT 3.5 and 4. Now, think of it, GPT 3.5 is the best free model available today. GPT 4 is not free, but arguably the best model available today. All right, so what I will now do, I will not have the time to spend on all of these biases, but what I will have the time, I'll have the time to show you 4 examples. Right, conjunction fallacy, overconfidence, risk aversion, and a CRT, cognitive reflection. Right, so let's talk about conjunction fallacy for a minute. So the classical test for that is what is called a Linda problem. So let's spend a minute here. So reading this. So Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. So now it's the task. Rank the following statements that could describe Linda from the most likely to the least likely. Linda is a teacher in an elementary school. A. B. Linda works at a bookstore and takes yoga classes. C. Linda is active in the feminist movement. D. Linda is a psychiatric social worker. E. Linda is a member of the League of Women Voters. F. Linda is a bank teller. G. Linda is an insurance salesperson. And H. Linda is a bank teller and is active in the feminist movement. Right, so take a sec now, think about it. What would you rank? How would you rank these choices? Right, so a very well-known research paper by Tversky and Kahneman in 1883 observed that 85% of people ranked the probability of C, that is, Linda is active in the feminist movement, bigger than the probability of H, which is Linda is a bank teller and inactive in feminist movement, bigger than probability of F, which is Linda is a bank teller. Now, why is, and this is a bias called conjunction fallacy. Now, why is this a bias? Why is this a problem? This is a problem because H is a conjunction of 2 events, right? So therefore, H cannot be more likely, observe that H, Linda is a bank teller and inactive in the feminist movement, is a conjunction of F, that she's a bank teller, and H, and C, sorry, that she's active in feminist movement. Therefore, H cannot be more likely than C or F. Right? So why is this a problem from the business perspective? Because people focus on wrong, well, less likely scenarios. Again, if this would not be some fictitious Linda, but rather be a business problem, right? thinking that H is more likely than F, right, makes you focus on a less likely scenario while ignoring something that is more likely to happen. So how does ChatGPT do on this problem? GPT 3.5 ranks C bigger than H bigger than F 100% of the time, right? So in other words, it's even slightly more biased than people are. Now, GPT-4 gets 100% correctly. That is, H is after C or F. Now here, of course, observe that whether it's more likely that she's a bank teller or more likely that she's a feminist movement, we don't really know that. But what we for certainly know from the rules of probability that H cannot be more likely than C or F. Okay, so this is kind of the classical formulation of this conjunction fallacy problem called Linda problem. Now, what did we do then? We then took a Linda problem revised, and again, take a quick look of what's going on here. Harmony is 34-year-old, widowed, and very clever. Majored the dark magic at the lab school, and so on and so forth, right? So observe that this is exactly the same problem, right? Where kind of all the words in a way have been changed, right? So the name Linda was changed to the name Harmony, right? That she's active, that she's a bank teller, and feminist movement changed to a bookkeeper, and this free butter flea movement, right? So some of these words are made so that they do not appear anywhere on the internet, right? So realize that this is exactly the same problem, right? Just with some of the words changed, right? So remember that in the original Linda problem, 85 subjects ranked C bigger than H bigger than F. ChatGPT 4 ranks C as the most likely, then H, then F. So in other words, it is, again, 100% biased. And of course, what's the difference? Remember that with the original Linda problem, ChatGPT got it 100% correct, is that, so ChatGPT 4, right, now essentially learned that this is a standard Linda problem, right? So once we give this exact text to it, right, it recognizes this as a classical problem. Now, of course, what we also know now is that GPTs are very much subject to conjunction fallacies, right? Because once we give them a problem that is kind of same as before, but is not appearing in the training data set that the models have, right? They're 100% biased. All right, so here we looked at how this changes across the different versions of GPT, right? So March 1st version, June 13 version, August 25th version, pretty much the same. Again, so no real difference. We then looked at how this changes across different models, right? So this is with Google Bard, right? So the original Linda problem, 21 out of, and this is based on 30 repetitions. So 21 out of 30 are correct, right? But often for the wrong reasons. So for example, here's one. Linda is a bank teller and active in feminist movement, is least likely because it's unlikely that Linda will have the time to do all of that, right? Now, of course, the revised Linda problem, that is the harmony problem, only 1 out of 30 is correct. And the reason is very much like human, right? I ranked H as most likely because it combines the two things that we know are most important for harmony, right? And of course, again, what that means, it means that these models, if will be used by managers or value chain partners or customers, right, would eventually lead to this problematic behavior where they will force you to focus on scenarios that are least likely while foregoing the scenarios that are most likely, more likely. All right, so this is one bias conjunction fallacy, and these models seem to have it quite as much as people do. Next one, risk aversion. So a classical test for risk aversion is the following, right? So you're giving a table of two options where one of them is safe, option A, and one of them is risky, option B, right? And then realize that option A is always the same, while in option B, the more favorable outcome starts to get better and better and better, right? At the very top row of this table, right, the expected value is of option A is 5, right? 5.5 times 50%, 4.5 times 50%, right? And in option B, it's also 5, right? 9 times 50% plus 1 times 50%, right? So in the first row, they have the same expected value. Option B just has more variance, right? And as we go down the rows, right, the expected value of option B starts to increase, right? While the variance also starts to increase slightly, right? So Holt and Laurie showed that about 50% of people switch from safe option to risky option at about row 6. That is, they need quite a bit of a premium in order to be able to kind of quote unquote buy that additional risk. Now, why is this a problem? It is a problem because employees play it too safe, right? Executives want to take them to take on more risk. So we replicate this scenario context-less just with this option A and option B, and then add three business contexts. So what these business contexts are is, for example, this is a procurement context. Imagine you are a procurement manager deciding how many widgets to order for upcoming sales period. Demand will either be high or low. Based on your analysis, you narrowed down to two options or two order quantities, A and B. Option A has a lower quantity than option B, but option A has a higher per unit cost. With 50% chance demand would be high, option A you will run out of inventory, yielding to a profit of 5,500. With option B, you will satisfy all the demand, leading to a larger profit of 9,000. With 50% chance demand will be low, option A, you will have little unsold inventory, yielding a profit of 4,500. With option B, you'll have a large number of unsold widgets, yielding a profit of 1,000. Right? Between these two options, which one is better? Right? And then the same thing in terms of the staffing context. Imagine you are a store manager, you're deciding on the number of sales agents, and so on, right? Again, the same kind of problem, right? One is in the procurement context, the other in the staffing context. And we have this staffing. So the experiments we've run with this staffing context is one on this store manager, another on emergency room staffing, right? So they're, again, emergency room and you're staffing nurses. Okay, so what do we get from ChatGPT? So here on the left is GPT 3.5, on the right is GPT-4, and in blue is the safe option, that is this option A. In yellow is the risky option, right? That is the option B. Okay, so let's look at 3.5 first. On the very far left is the lottery, right? That's the original experimental instructions that appear in the research papers, right? So the very troubling situation is in GPT 3.5 an equal expected value. Right? Observe that in the equal expected value, right, in the first row of this table, right, there's really no benefit whatsoever to go to a risky option B, right, because you have the same expected value, just a lot more risk. And GPT 3.5 seems to suggest just that, right, kind of very, very non-human-like. Now, GPT-4 is very much human-like, right? That is, it is going for the safer option all the time. Right? So what else? Notice that across contexts, things are quite different. So the original lottery, which appears in the model's training set, right, behaves differently from the inventory context, differently from the staffing context. Now, the two staffing contexts, right, store and emergency room, they're somewhat similar, right? And then 3.5 takes too much unnecessary risk, right, as we discussed earlier. I think another observation is quite inconsistent across models. That is, there's large differences between GPT 3.5 and GPT-4. All right, so let's move to the next one. System 1 errors, something called cognitive reflection test. So remember what System 1 and System 2 is, right? So System 2 is kind of purposeful thinking. System 1 is very much like instant autopilot-like decision-making processes. So a research paper by Frederick in 2005 proposed a set of 3 tricky questions that can measure someone's ability to kind of control their System 1 with System 2. And one of these questions is this. In a lake, there is a patch of lily pads. Every day, the patch doubles in size. It takes about 48 days for the patch to cover the entire lake. How long would it take for the patch to cover half of the lake? And again, think for a second about how would you respond to that question. System 1 response is 24, right? 48 divided by half of the lake. Now, of course, the System 2, that is the correct answer, is 47 because the patch doubles, right? So it was half the lake. Next day, it will be the entire lake. Why is this a problem? Snap judgments are often incorrect, right? So System 1 is our snap judgments. So what do we see with GPT? So this is GPT 3.5. right? And on the horizontal axis are the different numbers from 1 to 48, and on the vertical axis is frequency. And we see that the most dominant response is 24 days, which is system 1. Now, GPT-4, it goes 100% for system 2. BART also goes 100% for system 2. And what we're doing now, we are adding some context to this, like similar as we've done with risk aversion, right? We're kind of making this in a procurement context and in some other business context as well. The last one is overconfidence, right? So with overconfidence, so remember what we're doing in this research, right? So we have these 18 biases in total, right? So think of the 17 of them, right, are not overconfident. So 18 biases in total, including overconfidence. Now, for some of them, there are correct answers. Like, for example, here, right, there is a correct answer. The correct answer is 47. So we took those biases for which there is a correct answer, and we then, after GPT gave us a response, so let's say here it told us 24 days, right? We would say, how confident are you in the fact that this is 24 days, right? And it gave us the number, how confident it is. So what we then did is we basically plotted the percentage correct, right, on the horizontal axis and a percentage confidence on the vertical axis. Now, in a well-calibrated decision maker, right, should have this percentage correct and percentage confident should be about the same, right? So this should be like a red line, right? Basically, if you are 50% correct in responding to some questions, you should be about 50% confident that your response is correct. Now, of course, what we observe is ChatGPT is almost at the very, very top. In fact, it is almost, it thinks it is almost 100% correct, no matter whether it actually is correct or incorrect, right? So, in other words, ChatGPT is massively overconfident, right? So far we have the results here for 3.5 for GPT-4. This is in progress because it relates a little bit to all these different contexts that we are now working on. So again, why is this a problem for business? Because overconfidence leads to underestimation of risks. Well, in any case, so if you want to read more about this research article, so you can go to the Social Sciences Research Network. So here's the link up on the top there, right? So the version that is currently online is from the 25th of May, right? We are now revising this research paper, and the newer version will be available pretty soon. So to summarize, as large language models continue demonstrating human-like abilities, people will use them as advisors and delegates in multiple decision situations. People inside your companies will use them, your value chain partners will use them, and your customers will use them. Right? It is therefore important to ask ourselves a question about their decision biases in the sense of thinking fast and slow, right? The biases that I was talking about, right? And of course, there are arguments both pro biases and against biases, and so therefore, kind of that makes it an interesting research question, right? So what we observe here is that some biases are not present. Again, I did not have the time to talk about it today, but for example, these models don't seem to have the sunk cost fallacy. Some biases are present in a way similar to humans, such as conjunction fallacy. Some biases are present but different. For example, there's even more overconfidence than it is with humans. And manifestation of these biases depends on the context and on models and versions. All right. So here I put a quick summary, right? So remember the table of 18 biases, right? So which ones are similar, right? I kind of highlighted them with the straight line, and biased but different, I highlighted them with the dashed line. Right. So I think the last thing I want to say is that if you want to learn more about this, please consider attending an executive education program called Strategic Decision Making for Leaders that myself and my colleague Enrique Decidue are teaching. So we have several offerings. The first one is at the end of January in Abu Dhabi. Then there is one in Singapore, and there is one in Fontainebleau. The dates I don't really remember the dates exactly, but they're all online. All right, so with that, I'm done with my presentation. And so, Virginie, could we now maybe go back to you to
yes, thanks a lot for
look at the questions?
Yeah, thanks a lot, Anton, for the presentation. Very insightful, especially because we are all using ChatGPT every day now. So because we're going to move to Q&A, please, everyone, feel free to add your questions in the Q&A chat. You can also upvote your favorite questions, so we know which one to prioritize. And I'm going to start with one question for you, Anton, which is considering the very good results, the very interesting results from your research, and considering that there are still a lot of bias for ChatGPT, do you think it justifies the necessity for companies and businesses to hire prompt LLM engineers to ensure the quality of the results they're going to get from ChatGPT and other LLMs?
Yeah, thank you, Virginie. So, well, the companies definitely need to look into this. Whether the prompt engineering is exactly the correct solution, I'm not sure. But think about some of the results, right? So since they are quite different in terms of the context, right? So the same question, right? If we ask in the procurement context versus we ask it in let's say in staffing, right? And it gives significantly different results, right? I believe that companies really need to fine tune this to their specific situations. Right, which is very different from humans, right? So again, this risk aversion, right? So humans have it, right? And whether they are working as, procurement managers or whether they're working as staffing managers, they kind of come with it, right? But these models seem to treat the procurement context very different from staffing context, and most likely they will treat kind of all other contexts somewhat differently. So the companies definitely need to be aware of that.
Okay, thanks a lot. Very clear. So one of the most upvoted questions for you is regarding the overconfidence of ChatGPT. So I think it would be great that you re-explain the definition of overconfidence. And the question is, why is AI so massively overconfident? Is it a reflection of what has been digested online?
Okay. So in fact, in a longer presentation, I have an additional slide about this, but let me talk about this now. So now, what is the definition of overconfidence, right? Overconfidence is this tendency to overestimate one's knowledge, right? Sort of, I think I know more than I actually know, right? Now, so why are these models overconfident, right? And so here, let's go back a little bit to how they're trained, right? And remember that the first process is we're simply learning from data to complete a sentence, to complete the paragraph, right? Right? Then this creates a model that already can do everything that GPT does, right? But then to improve that model, for it to give results that are kind of liked by people more, is the second step of reinforcement learning from human feedback. Right? So there is a research study from OpenAI themselves, which showed that overconfidence is 100% an artifact of this reinforcement learning with human feedback. That is, the underlying model that is trained is almost perfectly calibrated, meaning that if it thinks that meaning that if it is 30% correct about something, it thinks that it's 30% correct, right? But apparently, when it gives such responses to people who are doing this reinforcement, this human feedback, people don't like those responses. They like responses that are, I am very sure, right? So in other words, overconfidence comes, again, that's not really our result. That's a result of ChatGPT researchers themselves, is that this comes from that second step of reinforcement learning with human feedback. Which in a way, I think just it's a somewhat side remark, is that you can think of that what makes GPT successful is also what makes it behavioral, right? So kind of this second step, this reinforcement learning with human feedback, right, which is an ability to kind of produce results that people will like, right? To produce responses that people will find helpful, right? That is where a lot of the biases is introduced.
And I think one question that can arise from this is, do you know, like, because you tested a few tools, right? Not only ChatGPT. So did you notice any difference between all these different vendors? And do you have any recommendation?
Okay, yeah, let me give a slightly more expanded answer to this. So this particular research, so the research paper that we now posted online, right, eventually went into two different paths, right? So now they're actually, we're working on two different research studies, right? One is very much what I presented today, where we take different contexts, right, and we look at how specifically ChatGPT behaves in these different contexts. The other is where we look at how different models and versions of those models behave. Right. So basically, we are more or less done with this kind of context problem, but we are not quite yet done with how the different models behave. So I mean, we are working on this. Hopefully soon we'll have the results. But right now, apart from this kind of very few, like we tested something on BARD, right? I don't have a complete picture whether some of these models are kind of systematically better, systematically worse. Now, Virginie, let me also maybe say something else, which is also we found to be very, very curious, is that, so as you may know, there are different ways to interact with these models, right? So one is just with the web interface, right? That I think how most people are interacting with it, right? There is, an app on the smartphone or a website, and you come in and you type something there, right? Now, there is another way to interact with it with an API. So API is application programming interface. Right, that's basically, think about like a one computer program is talking to another computer program, right? So what we have a code written in Python, which then sends a request to GPT, right? GPT then sends a request, send the response back. So, and the reason we look, so we're doing this with API. Now, this particular study is done with API. Now, why is it done with API? Because that's how we believe most apps will be done. Now, think about it, how the Walmart is interacting, how the Walmart's negotiation tool is built, right? It's not that somebody's sitting and typing in the questions there in the web interface, right? It's an API, right? There is a kind of one program sending requests to LLM, right? What we observed is that there is a big difference in biases of a web version and the API version. Like, I would say substantial. Like, in fact, not even very clear to me why.
Yeah.
Yeah. There are certain settings of a web version, but even when we set the API to the same settings as the web version, we still get quite different results. So my intuition is that, I mean, as you know, there are various kind of safeguards and guardrails and so on that are put into the, and my intuition is that there are more of them in the web version than in the API. API is still kind of a relatively small set of more or less professional users, right, who can access it that way. Kind of the, the billions of consumers or people cannot do that, right? So therefore, that's I think that's what's going on again. But I think it's also another kind of very curious. If you think about now these biases with humans, right? It almost would depend kind of how you ask it, right? If you ask it in the morning, you get something else. If you ask it in the afternoon, you will get something else. No, that for people, it's very, very stable, right? But with this model, seems to be very unstable.
Great answer. And actually, it's very interesting because you just replied to a question that's asked, is the bias related solely to the data, also because of the models and the algorithms that are used? So
well, yeah. So here, I would say that, let's think about this way, right? So these biases in humans, right? There's about 50 years of behavioral science, right? So today is a fantastic day, right? Because it's exactly 1 year anniversary of release of ChatGPT. So not quite this day last year, but I would say in the very early December last year, my PhD. So most of this work is in fact done by my PhD student, Yang Chen, who is I believe the first author on the paper. So right, and so about maybe December 7th last year, Yang came to me and he said, well, how about we do this? And I said, oh, it's a fantastic idea, but I realized that there's only 1 year worth of behavioral science progress on this, right? And so I think this is a fantastic question, right? So, for example, separating these biases in terms of what comes from training the actual model from the reinforcement learning step. How much of this is due to the various guardrails and safeguards that are put in the model? Right. So I think these are all fantastic questions, which I think from the behavioral science perspective are also fascinating, because kind of we have always been kind of investigating these biases in humans, and have been coming up with the ways to de-bias humans. We were coming up with ways to benefit from the biases of humans, right? Mm-hmm. So again, think of these biases are not necessarily bad. They also allow for nudging in an efficient way, right? So for example, you may, one of the classiest examples is that as people are filling in the forms for the driver licenses, there is a little checkbox which asks, so in a kind of an unfortunate event when you die, right, in a car accident, do we have a permission to use your organs for transplantation, right? And so initially this question was asked in the same way, do you give a permission, right? And I don't remember exactly, but let's say 20% of people check the box. Then this question was changed to default being that you are giving a permission, and then so do you not give a permission? And the same 20% of people check the box, right? But that means that the kind of the quantity of organs increased fourfold, right? So again, so these biases are not necessarily bad, right? But we need to understand what they are to design processes around them, right? And with the model, with these LLMs, what we see is that they're a lot less stable. Things seem to depend on kind of many things, like the version of the model, the context in which you ask it. And so to me, it's still kind of, we're in the very early days of understanding these biases. But I think what's quite clear to me is that we really have to be thinking about that, right? Because people are using this, right? Think about it. 53% of Americans used it for financial advice, and that's from July. Yeah. By now, maybe 80% used it, right? So
really. And I think an interesting question also that arises is, are there any biases that are new for us that are actually kind of invented by AI? Do we have anything on this?
So fascinating question. So I don't know, right? And so here I would not be very overconfident, right? Is that what we studied here is we started from the biases that, we started from the list of human biases. Right. So yeah, so in fact, that's a fascinating research idea. I will even write it down, right? So thank you so much, whoever asked this question. Right. So very interesting. So in short, I don't know, but this is a fantastic question to investigate.
Great. Thanks, René, then, who asked the question. So another question, also very interesting question, is, so let's say we can prompt the model with a sentence like, keep this specific bias in mind when you respond to this question. Does it give bias-free responses?
So we kind of colloquially experimented with this. We did not really do a full study, right? So where we tried it with the harmony problem. Right. So remember, so let me remind you what's going on here. So there is a classical way to test for the conjunction fallacy called the Linda problem. Right. There is a Wikipedia article on the Linda problem. Again, it appears maybe in tens of thousands of different documents. Right. So GPT 3.5 had no clue. GPT-4 essentially learned there is something called Linda problem, and there is a particular correct way to answer. Right. Now, when we change this Linda problem in a very nuanced way, that is, we change the name Linda to a name Harmony, instead of being an anti-nuclear demonstration, she is whatever, a witch or something like this, right? So GPT-4 again was completely clueless. Now, what we asked it, keeping the conjunction fallacy in mind, right? Kind of what should you tell me about harmony, right? So we didn't really change things much. Right. So in other words, it doesn't, I think that the good way to think about it is that it didn't really learn anything about conjunction fallacy, but it learned about the Linda problem.
Right? Yeah, that's true.
Then maybe another way to respond to this question is that in most decision situations, these biases, the human biases, do not appear in isolation. They appear jointly. Right. So therefore, like for example, again, with that particular exercise, we knew that this is a test on conjunction fallacy, and we said it. Think about conjunction fallacy, right? But in numerous business situations, it's like multiple biases together, right? There can be a sunk cost and the risk aversion at the same time, right? So prompt engineering that way, I'm not sure how how pragmatic that would be. In a sense that you would need to understand what kind of biases would be applicable in this situation first.
Yeah, I think.
Yeah, Virginia, yeah, go ahead.
No, I was going to elaborate on this because another question that was voted was, how can this bias within the LLM models be resolved, and should regulation look at it, and what could they do about this?
So, okay, in my opinion, so first thing first is that the word bias would have very different meaning in different contexts, right? So bias is like, gender bias or sexual bias and so on, right? So these are the things that I believe are important to deal with regulation-wise, right? So here we're talking about decision biases, right? So the decision biases in humans, right, they have evolved kind of through the hundreds of thousands of years of human evolution, right? So the reason we people have these biases is because it's a way for our brain to save energy, right? So the reason people have these biases is because it's easier for us to live that way, right? And in the vast majority of situations, right, we are actually better off by having these biases than not. Now, think about the risk aversion, right? So what is really risk aversion, right? Risk aversion is the following kind of historically, right? It's the following question, right? So if we are in a particular situation, right, is it more important for our survival, for our biological survival, right, to engage in low-risk activities or engage in high-risk activities? And the answer is, of course, it's better to engage in low-risk activities, right? Yeah. Then, when would we like to engage in high-risk activities? When the benefits from doing so are really, really big, right? Because if I, as an individual, engage in high-risk activity for a little benefit, something happens and I die, right? That's kind of it, right? All right, but now think about the big corporation, right? In big corporation, there are maybe, 1,000 different projects at the same point in time, right? And so each manager would have their own kind of biological tendencies to play it safe. But an executive at that company don't want them to play it safe, because the executive will say, well, of those 1,000 projects, 200 will fail. And I, as an executive, I don't really care which 200 will fail, right? What I want all of them to be, on average, kind of a higher value, right? Some 200 will fail. But of course, each individual manager really cares about their project not failing, right? So therefore, kind of these biases, they are helpful for us biologically, for individuals, right? But they may not be, but they may be problematic or hurtful, right? In a modern day society, right, where kind of the biological survival is of lesser concern, right, and rather we care about other things, right? So that's a long answer to this question, is that the biases we're talking about here are not the ones that are necessarily subject to regulation, right? These are decision biases that we developed evolutionary.
And I think some people are actually wondering if it's not possible then to go back, I would say, directly to the algorithm to understand the behavior of the ChatGPT, and then rather than doing experiments, really trying to understand at the core what's the issue.
Well, so here we need to understand that. Okay, how should I put it? So thinking of GPTs as algorithms, I think, is somewhat misguided. These are such enormously complicated models that we do not have a very good understanding about why they do something, right? About what they do or why they do it. Right. So in fact, very similar to human brain, right? We don't really have a very good understanding about why, our brain is doing risk aversion, or this, 24 days on lily pads versus 47 days of lily pads, right? So to me, the approach we take here is, in fact, a I would say, the most reasonable one, right? Which is to interact with the system in its totality, right? Rather than try to understand the nuances of the algorithm. But some things, like, for example, this distinction between RLHF and the model by itself. So this is what we can do, right? Because these are like the kind of mega building blocks of the algorithm. Right?
Yeah.
But going further down would not really be helpful, right? Because these models are, so, you know, these models are not algorithmic in that sense, right? In fact, they're very much, I would say, they're very much probabilistic. So again, let's go back to an example that I gave. We all live in a yellow, right? So I think that majority of kind of Western civilization people would say that the next word is submarine. I once taught in an executive program for a group from Africa. Now we're Lagos, from a business school in Lagos. So that's what, Nigeria, I think, right? So I asked this question to them. They say yellow house, and I said, whoa. And you see, and apparently, kind of probabilistically, right, for us, the word submarine is very likely, right? They did not really associate we all live in a yellow with a submarine, right? For them, that was a house, right? So in other words, what these models are doing, they are ultimately probabilistic, right? They are kind of saying something with a certain probability, and the way these models are trained is so that whatever happens with these probabilities is most useful for the users. These models, in a way, are creating outputs that we will like, right? That people will like, will find helpful.
Yeah.
Right now, Virginia, I'm looking at the clock.
Yeah, we should wrap up for sure.
Yeah,
I see a lot of also technical questions, so I think it will be nice if you guys can reach out directly to Anton for your specific technical questions. So now we can wrap up for the end of this session.
Absolutely.
I don't know, Anton, do you have anything final?
Well, no, I think, again, let me, I will not really share anything, but just to wrap up. So what are we doing here is that as these large language models demonstrate human-like abilities, more and more people will use them as advisors or delegates in certain decision tasks. And I want you to think that these will be people inside your organizations. Like Gartner predicts that 100 million people will have robo-colleagues. These will be your value chain partners, right? If you do it or you don't do it, your suppliers or your buyers can be using these LLMs for their decision-making that affects you, as well as your consumers, right? If now you are thinking that you're marketing to a person, marketing to a human, right? But if that human is using an LLM, you really need to be thinking of marketing to a model rather than marketing to a human, right? And all of that makes it very important to understand the decision biases of these large language models. There are some arguments for why we should see the biases, such as these models are trained on human data, as well as the arguments against biases. I mean, after all, these are computer models, right? They can calculate things kind of and be fully rational. And so what we have here is one of the first studies, research studies of this kind, where we took the typical decision biases of humans and we replicated them on ChatGPT, first with the original experimental instructions that were used to uncover those biases, and then in reformulated contexts, specifically in business, right, such as the procurement context, right? And what we observe, I think, very briefly, is a mix of things. Right? Some of these biases exist, some of these biases don't exist, some of them are smaller, some of them are bigger. And perhaps what's troubling is that how they manifest depends a lot on the model and on the context. Okay. All right, so now, Pascal, I'm not sure who, but we have, I believe, a couple more slides to wrap it up, right? All right, so fantastic. So again, thank you everyone for attending. Now, I would also like to point you to a new series called INSEAD Explains, right, where multiple faculty explore the complexity of digital technology and discuss their impact on business management and society. The one that is launching today is, in fact, on generative AI specifically, again, realizing the date of a year since ChatGPT's launch, right? And the first videos are available on the INSEAD YouTube channel, on the Knowledge LinkedIn, and in the Learning Hub app. I would also like to point out to this program called Strategic Decision Making for Leaders. If you would like to learn more about this kind of decision biases in humans, decision biases in AI, and what can we do about that, right? So I will teach in that program together with my colleague Enrique Ditchtue. Thank you so much, everyone.
Thanks, everyone. Thanks, Anton, for this.
I think we're right on time. Yeah, perfect.
Yeah, thanks a lot. Thanks, everyone.